In our previous video, we have seen that how to register a Docker executor to run our project pipelines. In that setup, we mounted the docker.sock file from the host machine into the GitLab runner, and whenever the GitLab runner was executing a job, the GitLab runner was actually mounting that docker.sock file to inside that Docker executor. So if you can see here inside our GitLab runner service in our docker-compose file, we are using the volumes, and here we are mounting the docker.sock file from our host machine. This is our host machine path, and this is the path inside the GitLab runner. Whenever we execute a job and the GitLab runner is setting up the Docker executor environment for that pipeline, it will actually mount that docker.sock file from the GitLab runner service into the Docker executor here using the Docker volumes. But here are some potential issues using this method of running pipelines using the Docker executor. So if you can notice here, since we are mounting the host machine Docker socket file, this means that we are exposing our host machine Docker engine to the project pipelines. And there is an alternate way using Docker executor without mounting your docker.sock file from the host machine into the Docker executor, and that is called docker-in-docker, also known as docker-din. So let's dive deeper and see how the Docker executor using a Docker socket file is different than using the Docker executor through docker-in-docker. In this video, I'll also give you a demo of how to register a docker-in-docker executor, and I'll also walk you through a brief comparison how Docker executor using the docker.sock file is different than the Docker executor using docker-din service. So let's get started. I have this setup from my previous video using the Docker executor by using the docker.sock file, and I have run this pipeline here which has already passed. I'll quickly rerun this pipeline and I'll show you guys how this docker.sock setup is working and how this is affecting our Docker engine on our host machine. So before that, I'll quickly show you the GitLab-ci file to see what we have in our pipeline. This is our pipeline script which is using the stage build. The tags are the Docker socket, so it will be matching to that runner using this tag. For the Docker image, we are using Docker 24 version. When this pipeline runs, first we will run the docker ps command to see what Docker containers we are seeing inside the pipeline, and this will make sure that if they are actually listing all the containers from our host Docker engine, this means that we are directly connected to our host Docker engine. Then we will run another container by using the docker run command, and we will be using the Linux image alpine. When we run this pipeline, we will sleep it for 60 seconds. So while the container is sleeping for 60 seconds, we can confirm on our host machine that this container is actually running on our host machine and not inside this pipeline runner. And once we run this docker container, we will do another docker ps command to see that we are listing both the containers from the Docker host engine and also from within the pipeline, which is actually this nested container. And then we will run another container, and this way we will make sure that we are running all these containers from within the pipeline actually on our host Docker engine. So let's run this pipeline and see how it goes. Here you can see that when we run the docker ps command, we can see all these containers from our host machine, including the ones run by the GitLab runner. So this is the one executed by the GitLab runner. This is our host machine Docker container, which we have run for the GitLab-server, and this is for the GitLab runner. Once we run this container, we can see that we have another container for the alpine image. We have all these other containers from our host machine. So meanwhile, if we switch to our host machine terminal and if we run docker ps command, we can see that we have all these running containers from our pipeline on our host machine, including the GitLab executor and also the pipeline executor. And we also have these parent containers, which are actually the GitLab-server and the GitLab runner. So now we have confirmed that when we run a pipeline using the Docker executor and we use the Docker socket from the host machine into the GitLab runner, all the containers, including the GitLab runner, the executor, and any child container within that pipeline are actually hosted on the host machine Docker engine. We can confirm that we have actually given access to the host machine Docker engine from within the GitLab pipelines. Now, what could be the potential issues with this setup? That if we move back to our GitLab-ci file and instead of docker run, we run this command docker rm and then docker ps-qa. So this will actually list down all the Docker containers, including the ones which are running on our host machine. That includes the GitLab-server and the GitLab-runner, and then the GitLab-rm will actually go through all those containers and it will remove all those containers. So this way, actually running any risky command which can affect the host machine or the running containers will actually affect all the containers on the Docker host engine. So now if we run this pipeline, this will first run this container from the Alpine image, then it will run another container from the Alpine image, and at the end it will actually remove all the containers, and we will see that our GitLab server or GitLab runner, everything is down because all the containers are deleted. And the other thing is, so the same way we are running these containers on our host machine, all the images downloaded by this docker run or docker pull or any other docker commands, those images are actually downloaded to the host machine storage as well. And when this pipeline exits, these containers will be removed, but all those Docker images downloaded by this pipeline will actually still exist on the host machine, and it can increase the storage usage as you are running more and more pipelines. So if we switch back to our host machine terminal and we run docker image ls, we can see this, that this Alpine image is actually downloaded by the GitLab pipeline, and as you are running more and more pipelines, you will see that the storage will actually increase due to all these downloaded images by the GitLab runner. Now we are moving to the alternate solution, which is docker-dend, docker-in-docker. But before moving to that, let's quickly revise how the Docker executor using Docker socket is working through a simple architecture diagram. So this is the architecture of Docker executor using the Docker socket file. So this is our host machine, and then on the host machine we have this Docker engine, and on the Docker engine we are running our GitLab runner, and when we run a pipeline, the GitLab runner will actually start a container called the job container, and in that job container we have this CI script that will do a Docker build and a Docker run. And when we run the Docker commands inside that job container, any container or any image downloaded by that Docker CLI will actually be hosted on our host engine. So here we are mounting the var/run/docker.sock file from host machine into the GitLab runner, and when the GitLab runner starts a job container, it actually mounts that same docker.sock file into the job container using the GitLab runner config file. This way we have actually indirectly giving access to the host machine socket from within the job container, and any container created from within this job container will actually be created on our host machine Docker engine. And this is what we saw already, that when you run your pipeline, you will see that all these containers will be running on your host machine, including the child containers from the pipeline and also including your GitLab runner container. So any potentially risky command will actually affect your host machine containers. So if you run a docker remove command from within your GitLab pipeline, that could actually remove all your containers from your host machine. Now let's move to the Docker-in-Docker service and how we can register a new GitLab executor using Docker-in-Docker. So I'll move to the GitLab dashboard. Here I am in my project. If I switch to settings, CI/CD, and under the runners you can see that we already have this one runner called Docker socket. I'll click on the new project runner. Here I'll give it a tag name called Docker-in-Docker. Any GitLab pipeline where I'm mentioning the Docker-in-Docker tag, that pipeline will actually be picked by this runner. And here I'm giving a quick description, Docker-in-Docker for this repo. I'm creating the runner. Next I'll copy this GitLab runner register command from here. So here I'm on the host machine terminal, and if I do a docker ps, I can see that I have two containers. One is the GitLab server and the other is the GitLab runner. I'll log into the GitLab runner command for registering a new Docker executor. And now I'll paste that same command which I copied from the GitLab runner registration setup, and I'll paste that command here. Before executing this command to register our GitLab runner, we need some additional flags for this executor, and one of them is the Docker privilege mode. So to use the Docker-in-Docker service inside the GitLab pipelines, you need to run the Docker in the privilege mode. So I'll pass this Docker privilege, and the other flag is Docker volume. So we are passing some certification so we can communicate the Docker-in-Docker and the pipeline through the TLS. So now let's execute this command, and then we'll see by running a pipeline. So I'll leave this as it is. I'll give this runner a name called Docker-in-Docker. The executor should be Docker, and the default image I'll be using is Docker 27.2.0. So our executor is registered, and now let's switch back to our GitLab pipelines and run a pipeline using this Docker executor. And here you can see this message that you have registered a new runner. Now if we move back to GitLab pipeline editor, instead of rewriting this whole pipeline, I'll just change this Docker socket tag to Docker-in-Docker. So now what the GitLab runner will do is that instead of picking the Docker socket executor for this job, it will actually pick this new Docker executor called Docker-in-Docker by matching this tag name with the tag we assigned to this GitLab executor when we were registering this executor. So now let's commit this and move back to the pipelines, and we can see that it is in pending. If we go back to the details, so I know all these errors we will be seeing in the next couple of steps, but the reason I'm not resolving all those in advance so that we can go through all these issues step by step, how we can set up the Docker-in-Docker service, and we will resolve each of this issue one by one. So the first issue is that the GitLab pipeline is unable to access the GitLab server using localhost. So if you remember from the previous video, we have actually set the Docker network mode to the host machine, so that way the GitLab runner networking is actually hosted on the host machine, and the GitLab runner can actually access to the GitLab server using the local host. First, let's try updating the networking mode inside this new GitLab runner. So I'll switch to the terminal. So if you have noticed from the GitLab register command, all these configurations are saved into this file. So I'll copy this path of config.toml and I'll pass it to nano, and now you can see here that we already have a Docker socket runner, and if you go down we should have another executor called Docker-in-Docker, and in our Docker socket executor you can see that the network mode was host. So that was the reason we were not getting that accessibility issues from the GitLab runner to the GitLab server. So I'll copy this network mode, I'll paste it here, and now I'll save it, and now I'll switch back to this pipeline and I'll rerun this same pipeline. And here you can see that the repository is now pulled by the job container inside the job container by using the git pull command. So we have passed this first step by setting the networking mode to the host, and now the GitLab pipeline container can get access to the GitLab server. The next step is that the pipeline is not able to get access to the Docker, and the reason is in our previous setup when we were using the Docker socket method, we actually mounted the Docker socket file from host to the container, and whenever we were running any Docker command, the Docker CLI was actually getting access to the Docker host engine using that docker.sock file. But since in this executor we have not mounted any docker.sock file, so we only have some certs and cache, if we mount the docker.sock file here, the pipeline will start actually working. But since we are not going to give access to the docker.sock file, so the pipeline is not able to get access to any Docker engine. So what we are missing here inside our pipeline is that we need some way to get access to the Docker-in-Docker service, and for that we need to get these services to the GitLab pipelines using the services, and then we are setting the service to the Docker-in-Docker service. So what does this Docker image does that this image, when this is run as a container, this container already has all the setup for a Docker engine dedicated and isolated to this container only. When we are getting access to the Docker engine from the Docker CLI commands from inside our pipelines, this Docker CLI will actually get access to this service which has its own Docker engine inside a container. So this way we are actually isolating our containers which are running inside the pipeline from our host Docker engine. And the next thing is we are setting up some variables. So the Docker engine inside this service is running on this URL called TCP Docker, and to get access to that Docker engine using the TLS, you need to set this Docker TLS certs to /search as well. So now let's commit these changes and see how this goes. Now the pipeline has run, but we are seeing another issue, and the issue is that since we have set the Docker network mode to the host, and as we have set the pipeline services to the Docker, we can see that the service is actually not starting because it says probably didn't start properly. And if we see this message in detail, it says that conflicting host type networking cannot be used with links. This would result in undefined behavior. And if we see here, the Docker CLI is not connecting to the Docker engine inside that service. The reason is this services container, which is called Docker is actually using some links for the container networking, and you cannot use both container links and the networking mode host for the same containers. To get rid of using the networking mode host, what we will do is that we will create another separate and a dedicated Docker network. We will call it GitLab-in-Docker. We will attach our GitLab server to that new dedicated Docker network called GitLab-in-Docker, and then when we are running our Docker executor, we will also attach that Docker executor to that same network. So this way our GitLab server and our GitLab pipeline container will actually be connected to the same network, and both of them can get access to each other through its container name. I'll switch to the VS Code, and then I'll switch to the docker-compose.yaml file. I'll add some script for adding a new network called GitLab-in-Docker. I'll name this network called GitLab-in-Docker. The driver will be bridge. Using the Docker host networking, two containers can get access to each other through localhost, the way we are using in the Docker socket mode. So what is different in the bridge driver is that two containers can get access to each other through the container name instead of the localhost. Since we need to attach our GitLab server to the same network, so the pipeline can get access to this GitLab server using the container name. I'll add two lines here called networks GitLab-in-Docker. So now we have attached this GitLab server to this network GitLab-in-Docker. I have created the new network here inside the Docker Compose file. The same way we have attached this GitLab-in-Docker network to the GitLab server, we will actually attach this network to the job container as well. Since we have updated our Docker Compose, we need to rebuild our GitLab server and our GitLab-runner containers. So I'll switch to the terminal, and here the containers are running through Docker Compose. I'll stop these containers using Ctrl+C, and I'll run this command docker compose up build. It will rebuild the containers from the updated Docker Compose file to start attaching the GitLab server to the new network called GitLab-in-Docker. So now if we do our Docker network ls, we can see that we have this new network called GitLab-in-Docker, and if we inspect this new network GitLab-in-Docker, we can see that the GitLab server container is attached to this network. Now let's go back to the runner configuration and also make the relevant updations there as well. So for that, I'll log in back to the GitLab runner container using the docker compose command, and now I'll update the GitLab runner configuration using the nano editor. So the first thing we need to do is to update the networking mode from the host to that custom network we just created. So as we do this update, the pipeline container, which is actually the job container, will be attached to this GitLab-in-Docker network, and as we have seen that the GitLab server is also attached to this same network. So both of these containers, the job container and the GitLab server container, can get access to each other through the container name. And since both of these containers needs to get access to each other through the container names, we also need to update the clone URL as well. So when we run the pipeline and the pipeline is trying to clone the project repository inside that container, that will also needs to be updated to get to the repository through the container name instead of the local host. I'll switch a little above, and below the executor I'll add this clone URL, and here I need to add the container name of the GitLab server, and since the repository is available inside the GitLab server container, so I'll add the container name GitLab server here alongside the port number, and I'll save this configuration. So now let's go back to the pipeline and rerun the pipeline. So here inside the GitLab server, I'll rerun this same pipeline. And now here you can see that everything seems fine and going smoothly. The repository is cloned, the Docker CLI is connected to the Docker engine, and again here you can see that when we do a Docker PS inside the job container, instead of listing down all the containers including the host Docker containers, it's only listing the container which we have just executed before, which is the Alpine image container. So now this way we have isolated the pipeline setup and its containers and its connectivity to the Docker engine from the host machine to a dedicated Docker container which has its own Docker engine. So now if we run any potentially risky Docker command inside our pipeline, it will actually not affect our host machine Docker engine, but instead its effect will only be limited to all the containers and to the Docker engine which is running inside that service called docker-in-docker. I'll rerun this same pipeline and we will go back to the host machine terminal and we will run a docker ps command to see that none of these containers are actually running on the host machine other than the executor container. And then we will log into the service container and we will run the docker ps command and we will make sure that only these containers are running inside that docker-in-docker. So now on the host machine terminal, if I run docker ps, I can see that I have these runner containers, but I don't have any child containers which I have executed inside that pipeline. Those child containers are actually not running on the host machine. And now if I log into this service container by using its ID and using the docker exec command, and if I do a docker ps here, I can see that I have these two child containers which I have executed from inside the pipeline. So this container is actually hosting all the nested containers from within the pipeline, and the GitLab runner containers are actually running on the host machine. So now if we run any potentially risky command or we remove all the containers from within the pipeline, that will only affect the containers inside this service container. But since this service is limited and restricted to this pipeline only, if you are running two concurrent pipelines, you will have two separate docker-in-docker services, and any commands you are running from inside this pipeline script, it will only affect the service attached to this pipeline. So this way we have completely isolated the Docker CLI and anything related to the Docker from the host machine and also from the other pipelines. Now we have set up the docker-in-docker service by registering a new Docker executor. Then we try to avoid using the Docker socket file from the host machine. So now let's go back to some architecture diagram and see what actually we did and how this whole architecture is working, including the Docker networking and also running the containers inside a service. This is the architecture of docker-in-docker service using the GitLab runner executor. The basic foundation is same. We have a host machine, and on the host machine we have Docker engine. So this was same for the Docker socket method as well. And then on the Docker engine we have our GitLab runner. That GitLab runner has mounted the docker.sock file, and this docker.sock file is needed. You cannot set up GitLab runner without mounting this docker.sock file, because the GitLab runner needs to run an executor, and inside that executor it will actually run all the Docker related stuff. This is needed. We are not going to get rid of this. This is always needed when you want to set up the GitLab runner. The only thing we did that we didn't mount this docker.sock inside this job container. So how it works is that on the Docker engine we have GitLab runner. When we run a pipeline, the GitLab runner will actually run a job container. That job container will be running on the host machine. As we have seen previously that when we run a pipeline, one container is running on the host machine and all the containers running inside that job container through the Docker CLI will be running inside the service containers. So here we are setting up the service where we are using the docker-in-docker image, and then we are running the script. So any containers or any images downloaded by these Docker commands here will be actually hosted on this service container called docker-in-docker. Once the pipeline exited or the pipeline runs successfully, this service container will be terminated, and we are also isolating anything running inside the pipeline related to the Docker to this service container. So when we run a pipeline, you always see two containers. So one is the service container and the other is the actual job container, where the GitLab runner is actually cloning the GitLab project repository, and then it runs the script path from that pipeline. So when the pipeline exits or the pipeline runs successfully, this job container and this service container will be deleted from the host machine. Since this service container will be deleted, all the child containers will also be deleted, including this service and this child container. And this way we are isolating all the nested or the child file containers created by this script from the host machine and also from the other job containers. And if we switch to the networking, this is how we have set up the network. So we have host machine, we have a Docker engine, and then on the Docker engine we have this GitLab runner, then we have a Docker executor where we have this pipeline job, and this job container was actually attached to this new network called GitLab-in-docker, and the GitLab server was also attached to this same network. Since both these GitLab server and the job containers are attached to the same network, they were able to get access to each other through the container name, and that was the reason we updated our GitLab runner configuration to update the clone URL to the GitLab server name and also update to the Docker networking mode to this new network name. And we didn't update the GitLab runner host, it is still attached to the network host, and the reason is the GitLab runner needs to verify the GitLab runner registration token with the GitLab server, and for that it needs to get access to the GitLab server through localhost. We can do that as well to attach all these containers to the same network and then use the GitLab server name instead of the localhost, but that's totally up to you. If you want to attach all the containers to the same network, you can do that. Then when you are registering a new GitLab runner and there is that URL called localhost, you need to update that to the GitLab server name. So that was all about the Docker executors inside the GitLab runner, where we have seen two types of executor. One is using the Docker socket from the host machine and the other is using an external service called docker-in-docker. Now what is the solution in case somebody wants to not use the Docker executors at all? Because at the end you may have some potential issues with the Docker-in-docker executor as well, because you are running the Docker container in the privilege mode, and I'll attach the link to the privilege mode security issues and you guys can go through it. If you want to completely avoid getting access to the Docker engine, whether it's the host Docker engine or it's the Docker engine inside that service called Docker-in-docker, there is another solution called google-kaniko. Google-kaniko actually doesn't need access to any Docker host at all. It is not dependent on any Docker engine at all, so you can use it completely independent of any Docker engine. In the next video I'll show you how to register a GitLab runner where you can use google-kaniko to build and push your Docker images without being dependent on the Docker engine.